Hey, Internet. My name is Bret. Welcome to this show. This is where we talk about Docker and DevOps, Kubernetes, containers, all the things, including cloud native and cloud, all the modern stuff in tech when it comes to infrastructure and taking your code and putting it on servers. So, if you haven't been here before, the format of this show is we take your questions throughout the show, throughout the hour. So, if you're here live, great. You can ask your questions of me and my guest. And I am usually here every Thursday. So, if you are watching this and it's not live, make sure you come back live on Thursdays. You can click the subscribe and the little dinner bell there that makes sure that you'll get a notification when I go live. You can come back and join us and hang out for a live chat. And this show is now sponsored on Patreon. So this show is because I am so passionate about containers and all the things that it gives for us. And I've now, because of a lot of you asking for ways to give back, buy us a coffee. Thank you so much for doing that. You can now join me on Patreon. The link is below. It's patreon.com/Bret Fisher. And I always thank you for your support. I'm very grateful for any of you that are willing to give back. And I'm excited today because it's one of my friends and someone I've known for years in the container community. He's a big deal, and I'm super excited to have him on the show, Phil Estes.
Hey, Bret. Great to be on, as usual.
I need to have like a little, like a little, like a little celebration or something, a little confetti.
Yeah.
So, in case you don't know who Phil is, Phil has done all sorts of things, but he's been around since the origin of containers. He was early days containers, and as a maintainer of part of the container community, he's actually been in the code, working, making these tools awesome, and still does that today, like 6 or 7 years later, right?
Yeah. Yeah, coming up on 6.
Yeah. And of course, he's a big fan of Linux. And in fact, let me tell you a little bit about his background, his little bio here. He's a distinguished engineer at IBM, which is also a really cool, big deal. And he's the CTO for Container and Linux Architecture Strategy at IBM Cloud. Now, Phil has been doing everything, including CNCF, Containerd project, which you'll see him all over the internet talking about Containerd. We're definitely going to get into that. And he's at a lot of IBM Linux events, CNCF events, and he's also, he has a ton of roles. So let me just list these off. He's the OCI Technical Oversight Board member and a CNCF ambassador, and he helps IBM product organizations use containers, Docker, and now Containerd in their managed service offerings in the cloud at IBM, and including the IBM Cloud Kubernetes service, which you should definitely check out. It's one of the big ones out there. And he's got a really cool Linux Foundation jacket from, I think, was that from LA? Was that when we were in LA?
Yeah. The hashtag
Diversity.
OSS diversity. If you took the speaker class, you got a nice jacket.
That was one of my favorite jackets.
Yep.
So, all right, you have had lots of roles over your career. We could probably take a whole episode and just talk about, I mean, we're both guys getting old, and we've got some experience behind us. We've been doing this Linux thing a while. Why don't you take us back a little bit, because those on the show that have maybe heard about Containerd and they understand it's somehow related to Docker, and maybe talk about the origin of these multiple container runtimes, and a little bit about that.
Sure. Yeah. So I think probably of most interest to folks who maybe, just the last couple of years have heard about Docker, heard about containers, heard about Kubernetes, is to understand that, prior to 2014, 2015, the technology that is so commonplace to us today was a set of kind of loosely coupled Linux kernel features that others had called containers. LXC was already existing and had existed for some time then. Other people had tooling built around some of these capabilities. So if you've heard of Linux namespaces and C groups, these were the building blocks that Docker then turned into a very, very popular, initially, developer tool, added this concept of images. So that's really that 2014, 2015 timeframe. And I even see Jerome here in the chat waving hi to us. He was very involved in those early days, as were many others at Docker. Building this initial tooling that caught on like wildfire. Um, very quickly after that, 2015 into 2016, Docker wasn't the only one with ideas how to assemble these Linux kernel features together. CoreOS came out with Rocket very soon after. And it was at that time that the Open Container Initiative was founded to hopefully have a place where everyone could agree on kind of a standard specification of runtime and images, so that if we ended up with a plethora of runtimes, we could at least all interoperate. We could be compliant with the spec. Um, you know, Years have passed now. It seems like decades, but it's only been a few years since 2016.
Yeah, decades of cloud time.
Yeah. Yes. Rocket was recently archived. There was just a tweet in the last month from one of the early founders of that project, kind of wrapping it up. It's now set to read only on GitHub.
Yeah, that's a good point. By the way, because a lot of people still ask, a lot of students in my courses ask about Rocket, and the problem. One of the challenges is the internet, the blogging and documentation on the internet lives forever. So that's a good point. If you're interested in, we're going to talk about all these container runtimes, but Rocket is no longer really one of them. It was, yeah. So sorry, didn't mean to interrupt, but
yeah, no, good point. So effectively, as the OCI was founded, Docker contributed kind of that core layer that dealt with these Linux capabilities, the things that we just talked about, namespaces and C groups. And that became this de facto implementation called Runc. Most people who've dug into what actually gets installed on their system with Docker will recognize that Runc is one of those components. If you poke around at the processes that are running, Runc is there. And so within a few months of donating that code out of Docker, Docker effectively went from this monolithic strategy to a tiered, set of components, with the Docker engine being the thing most of us interacted with. But underneath that was Containerd, which actually initially was just more of a management layer for the Runc processes that were started when you asked Docker to start a container, or you wanted a container paused or stopped. Containerd would, on behalf of Docker, manage the Runc process to make it pause or stop or get the status or tell you what PID it was on your Linux system. So that was kind of the introduction of a tiered approach to the Docker engine. And out of that came new ideas by the end of 2016 into 2017. Hey, we could have a core runtime for people that aren't interested in kind of the entire Docker suite of tools. That, for example, in the Kubernetes world, if we just take Containerd and make it a little more rich with an API and implement Kubernetes container runtime interface, you could run Kubernetes with Docker. You could do it with Containerd. And at the same time, Red Hat also was looking at the same thing and saying we could just take Runc in a small management layer. And so they created cri-o out of that as well. And so today, these projects all have, different focus. But effectively, when people think, what are the container runtimes that are out there, they probably think about Docker and Containerd and cri-o as kind of the main players. There are some others out there. The high performance computing space has a project that I just totally forgot. Singularity.
Yeah.
I totally forgot the name. The cool thing is most of the new ones that have popped up that maybe you haven't heard of, the OCI standardization has effectively made sure that everyone tries to adopt and implement that spec. And so we still end up, when we talk about container images, we're all talking about the same thing. We're all using the same registries. And so we're in a good spot, even though there is some choice and some debate about what should I use, and is this thing better than that thing. That's kind of where we are today.
Yeah, and I get this question a lot from people that are, they're diving that once they get past their first sort of Docker 101, and then they maybe even do a little Kubernetes 101, and they start to try to understand the internals, and they hear about things in Kubernetes like the kubelet, and then they learn, oh, there's something that, they have underneath the kubelet that's, it's controlling, and then they start to question what the differences are. Tell me if this sounds, I'm going to pitch you a comparison and tell me if this sounds crazy or if it's good.
All right.
Docker, like comparing Docker, Containerd, and cri-o. So those are like the ones that I know, like the Singularity and other ones that seem to be a little more unique, niche kind of thing. But to me, if I had to do like a elevator pitch, it would be Docker is the user-friendly version if you need to interact natively with the container runtime. Containerd is the universal one that works across the board. It runs underneath Docker now. It runs under Kubernetes. It can run on its own. And it's increasingly a wide array of features that we'll probably get into. And then cri-o seems to be exclusively focused on just being a Kubernetes runtime. And ideally, you're never really having to touch it. You're only going through Kubernetes to use it. Does that sound like a reasonable?
Yeah. Yeah. That's definitely a very reasonable definition or differentiation of those three. The only thing I would add is that because cri-o was built on a couple specific libraries that are outside of cri-o itself, so they have something, the container/image and container/storage, you can find those on GitHub. They've created their own tools to replace that kind of user-friendly Docker layer so that you can, yes, cri-o by itself is just that Kubernetes runtime, but you may be interested in, well, how do I do a Docker run kind of thing? And so they've created Podman, and Scopio is more that registry push-pull interaction, and Builda is analogous to Docker's build kit. And, how do I actually take content and build it into a container image?
Yeah.
So effectively, they've created a suite of tools that build around the same core content that then gives you some of those same features.
So in that case, what you're saying is, with cri-o, it's kind of expecting you out of the box to be using Kubernetes, Kubernetes as the interface, right? So you're presumably, if you're an admin, you're using kubelet, and then the other tools, the Builda and the Scopio and Podman, those are more user-friendly tools where if you're interacting directly with running in containers, building containers, container images rather, and if you don't have the ability or can't use or don't want to use a Docker tool set for just a Docker client, these other ones are a comparable equivalent. Whereas maybe Containerd, I know we've got CTR, right? That's the command line, but Containerd doesn't build, right? It doesn't build images, and it doesn't do all the things that you might use for Docker. I think that is a common question people ask around, could I replace if I'm just running Docker locally for development or testing, could or should I replace Docker with Containerd? My answer there is usually no, just because it doesn't seem to have as many features. It's not trying to scope itself to all of those use cases, right? Is that true?
Yeah, exactly. So, Containerd, I think we had the conceptual idea that it's always going to be embedded in something. So, for example, in the Docker use case, there's no need to use CTR to interact with Containerd because Docker is going to do that integration for you. When you're using Kubernetes, you're using kubectl or you're creating pods. And again, you don't need to interact directly with Containerd. CTR is there sort of for that sysadmin who does need to poke around and figure out what's going on.
Yeah.
But yeah, so we never wanted to expand Containerd to have that broad kind of developer use case, build use case. And the great thing is we feel like BuildKit and Docker are filling out that portfolio so that we don't need to do that in Containerd.
Right.
BuildKit can talk directly to Containerd and do all the cool, build features, caching, etc. It makes no sense to add that to Containerd as part of the core project.
Right. Right, because Kubernetes currently doesn't build images on its own, so it's not really it's not a necessary part of the spec, right, for a container runtime to even
Right.
do that. Yeah. Yeah. And then if someone is interested in those kind of things and they're running on Linux and they don't want to use Docker, then the trio of Red Hat tools would be a good alternative.
Yeah, yeah, and Red Hat's model for their developer community. If you look at their documentation for UBI, their Universal Base Image or OpenShift, that's where they direct their developer community on Fedora or on RHEL. Here's we're delivering these in the Yum stream of applications. Install Podman, Scopio, and that's your tool set. So
Right.
definitely on that side, that's they're directing developers to that suite of tools.
All right. So I think that we get a good understanding of like where these three tools are, maybe where they're headed. Um, that's why I still, when I do my container training for people, I still start them out with Docker because it's still to me the easiest single utility that does it all as long as you learn all the commands and all the different subcommands. And then I feel like we sort of grow from there. And in fact, you and I were just talking before the show. We were talking about that KubeCon has been canceled as of this week. KubeCon EU is not necessarily canceled; it's postponed till the late summer. But it was where we were going to be, talking about Container D. Both of us actually. Jerome, who's also in the chat today, Jerome and I were doing a workshop on Container D and basically trying to translate someone's skills from Docker over to Container D if they're shifting from maybe a Docker centric workflow to a Kubernetes centric workflow. Maybe they if they do get into trouble or they need to get more into the underlying tools, how would they take those Docker the way that they understood Docker before and translate that to Container D? Because some of the commands are very similar and some of them are quite different. And
Yeah.
can you talk a little bit about like where Container D is used? I know you have a list on the website, but where I mean, obviously you can use it anywhere if you want to manually install it. But like, are there a bunch of products out there that are already using it?
Yeah, so again, with our vision of kind of being embedded in other systems, something that people may have heard of, K3S from Rancher and all the work Darren Shepard has done. He builds Containerd directly into that K3S binary, and so maybe you don't even know that the runtime underneath that minimal Kubernetes. For people that haven't heard, K3S is kind of a slimmed down Kubernetes that still conformant, still has the API, but takes out some of the heavier weight components of Kubernetes you may not need. So yeah, there's several use cases like that. Alex Ellis, who you and I both know, recently built FASD. So again, you can use OpenFAS on top of Swarm, on top of Kubernetes, but now it's also possible just to say, hey, Containerd has this nice API for managing container lifecycle. How about I just put the OpenFAS on top of Containerd directly and drive it that way? So that's kind of one use case or set of projects and products using Containerd. The other kind of at a more natural level is just any kind of managed service, Kubernetes service in a public cloud. You mentioned at the beginning of the show, IBM Cloud Kubernetes service switched to Containerd just about a year ago, or actually a little over a year ago now. So again, when you create a cluster on IBM Cloud, you don't need to know it, uh, but for operational reasons and Containerd simplicity, it becomes easier to manage these clusters when Containerd is there and doesn't require Docker to be in that call stack from the kubelet down to run C. GKE just announced on Twitter a month ago, maybe, that they had Containerd in beta for about the last year, and now I believe in GKE when you provision a new cluster, you're going to get Containerd by default as the runtime. So you've got these embedding use cases. You have kind of just using it as a Kubernetes runtime. And then I'd say beyond that, most of what we're seeing is interest around the extension points in Containerd. And so snapshotters are one popular extension point. Um, the Docker world, you would call those graph drivers like overlay, device mapper, Btrfs. Again, sort of the beginner user probably doesn't care, doesn't even know maybe what these things are, but these are the file system technologies used to handle the layered file systems of containers. In Containerd, we made a snapshotter API in a way to make it pluggable to add your own snapshotters. And so a couple interesting use cases in the high performance computing world. So CERN and many other labs around the world use distributed file systems. If you think about a physics experiment that has all these models and libraries, they have container images that approach tens of gigabytes. And the common way of, hey, Docker run, my physics project is kind of, okay, I can do that on my laptop. Okay, 20 gig is pretty big, but I can deal with it. Now think about a cluster with thousands of CPU cores who all want to run this experiment in parallel. You really would rather they just talk to the distributed store that they're all connected to, and these layers already exist, rather than pull down 20 gig to every single box in this cluster. So there are some new snapshotters, remote snapshotters that are in flight. There's a great talk at FOSDEM, and there was going to be a great talk on the same topic at KubeCon EU. I'm sure it will show up other places, and again, hopefully, many people will be there later in the year. But the implementation of these remote snapshotters is a new area of using Containerd's extension points to do interesting optimizations like my images are already in this store. Please don't go talk to a registry and pull down 20 gig because they're already available in this shared distributed file system.
Yeah.
So yeah, that's was kind of longer than I hoped it would be, but those are three kind of classes of use cases we see: the embedding, using it as a Kubernetes runtime, extending Containerd to do interesting things.
Yeah, the snapshotting, I'm glad you clarified that because I watched your KubeCon San Diego talk or the summit, the
Yep.
Containerd summit, and I wasn't quite understanding. I'm glad you compared it to graph drivers and Docker because I wasn't quite understanding the snapshotters. Was that like a backup? Like what was that? What was that all
Yeah,
about?
yeah,
Yeah. Um,
yeah. Terminology wise, if you know Docker, graph drivers is a good analogy.
yeah. And so Containerd it works on Linux and Windows. What's the deal with
Yeah,
Windows?
yeah. So Microsoft, we have contributors and maintainers from Microsoft who have been maturing that support. It's always supports as a generic term. So yes, it's been running on Windows for a couple years now. What's been happening more recently is a refining of the model in which containers run on Windows. So if you've heard the WCOW or LCOW, so Windows containers on Windows, Linux containers on Windows, there have been a lot of advancements in the Windows kernel and implementation to support these different modes of operation, different enhancements they've done on the Microsoft side. That those features are just now arriving in Containerd, including complete CRI support. So CRI is that interface to Kubernetes, so you can be a Kubernetes runtime. So 1.3, which is a release we already did, and 1.4, which is coming up. These are really a couple releases where you're seeing a lot of improvement, again, coming from the Microsoft team and some other contributors to improve the Windows support and make it even richer than it has been.
Yeah, very cool. I know the the Windows side is definitely taking a lot of work, and of course, due to Windows release cycles and stuff like that, having to add all that stuff in the kernel maybe takes a little bit longer than the Linux side.
Yeah.
And I know we've got a 1.4 upcoming. That's like the next major version of Container D that's coming out. I just posted in chat the link to the list of milestone stuff there. Um, is there anything in there for one of the questions I actually have is, as if someone's running Kubernetes, right? So like you talked about earlier, maybe not so many people are diving into Container D features themselves. They're probably using it through a higher level tool. And of course, if you're using Docker and Docker's running Container D, then you kind of have to wait for, if there's anything new in Container D, then that has to be exposed through Docker, I assume. So you gotta kind of wait on
Right.
the Moby repo and the CLI or whatever. So there's a big feature that we've been talking about in the community for a while, the C groups V2. What is that? I mean, backing up, we all when we all learn containers, we tend to learn a little bit about the fact that they use these two features of the Linux kernel called C groups and namespaces, and we've never really talked about versions before. That was just a thing the kernel did, and now there's a lot of chatter about the C groups v2. What is that?
Yeah. So I'll explain it at my non-Linux kernel guy fashion because I think there's more to it than even I fully grasp.
Sure.
But yeah, you made a good statement a minute ago. You can think about any kind of feature in containers really floats up through these multiple layers, and so things change in the Linux kernel. Sometimes that takes years. So cgroups v2 has been coming for a very long time.
Yeah.
Um, that has to come and be in distribution kernels. So it's not enough that it's merged into Linus Torvalds, Git tree. Distros then have to say, oh man, we gotta there's some tools involved, there's some boot time setup. So the actual move to cgroups v2 is really a very recent thing for distros. Fedora was first. I think Ubuntu is next major release will be cgroups v2, or at least have this hybrid capability. Then Runc needs to support whatever it is that Runc does to set up cgroups at that very low level. And then higher level runtimes, cri-o, containerd need to support that. And then, of course, Docker on top of that. So yeah, there's been a ton of work going on in that space. cgroups v2, to specifically answer your question, corrects and enables some features that didn't exist in cgroups v1, some limitations, nesting and the out-of-memory killer and some other things that have been troublesome, especially as containers have kind of taken the world by storm the last 5 years. Things like the integration of user namespaces in C groups has been hard because of needing to have root ownership to do certain things.
Yeah.
And so being able to have unprivileged nested C groups and things like that. So these are aspects of C groups v2 that are enabling things to get better down the line as all these layers, implement and enable these features.
Yeah.
So that's kind of what you're seeing now. cri-o and containerd are in the thick. I think cri-o maybe it's mostly complete. Containerd is very close to being complete to fully support cgroups v2. So yeah, that's been a big effort.
Is it something where it's one or the other? Like you're using the original C groups, I guess we'll call that V1, and then you're either using V1 or V2 on your system?
Yeah, that's something I need to learn more about because I know at the distro level, which I already mentioned,
Yeah.
I think some of the distros are choosing kind of a hybrid thing because again, every application that knew about cgroups v1 until it fully knows and supports cgroups v2,
Right.
you don't want to stick your users in this hotspot of,
Yeah.
oh no, half my applications that needed to set memory limits or block I/O limits don't know how to do it in the cgroups v2 world, and so they're broken.
Yeah.
And so I think there's kind of this hybrid time when people are going to have to kind of enable both in the distro, and then all applications will need to figure out cgroups v2 because container runtimes are a big user of cgroups, but there are other things on your system that try and use the cgroups interface to set up limits and et cetera.
Yeah. I mean, because C groups has been around a long time, right?
Oh yeah.
It's pre-Docker, right? So Docker
Oh yeah.
and
Yeah.
all these original tools. So often, because I don't really know what I'm talking about when it comes to kernel development and like the status of the latest Linux kernel, minor version and stuff like that. And I tend to loosely talk about it when I'm giving talks around like Docker in production and containers in production and talking about kernel versions. And I give people tips like make sure you're on a 4x version of the kernel because 3x is super old. It was actually around before containers were even the modern
Yep.
idea of what we think of as containers was invented. And there have been a lot of, especially in that like 3.11, the 3.18 area. Like there was some known performance and issues there. And so when I look at this V2 stuff, I see people talking about like kernel 5 dot something and a lot of
Yeah.
this C group stuff. And that just makes me think, yeah, it's definitely going to take a while for those of us using Docker and Kubernetes. And that's really the way we interface with this stuff. Like yeah, like you said, we're gonna have to wait for the major versions, the breaking major versions of our Linux distributions before we can really take advantage of this. But it's cool to see. Obviously, like you said, the Run C, the stack of tools all have to support it, and the low ones have to support it first. And
Yep.
yeah, it's really interesting. And all this is in open source, so it's like these groups that aren't exactly working for the same people don't have necessarily the same time and goals. It's pretty cool to see it happen.
Yeah, yeah, it's pretty amazing, and it's one area, people assume there's, this, and maybe again, it's more visible to me being in this ecosystem, but I assume some people see, oh, cri-o versus container D, this is a big fight, but cgroups v2 is something we're actually working on together, and we have maintainers who work on both and have submitted patches to both, and
Yeah,
so yeah, the open source world has all its bumps and bruises, but times like this, it's pretty cool to see
yeah.
how well it can work together when you get a good group of people, all trying to accomplish a set of, milestones.
Yeah, and I mean, that's part of your role too as a maintainer. You probably have a lot more insight on this than most people, where you see the different companies, the different organizations, the individuals that aren't even associated with an organization. They all have their different ideas about how to implement this stuff, and you're there to one of the things you have to probably end up doing is just making sure that we can all eventually agree on some things so we can move forward.
Right. Yeah. Yeah.
Yeah, and and you talk a lot about when you talk to Container D and you talk at KubeCon, DockerCon, all these different conferences all over the world about Container D, keeping everyone up on the status of Container D. That is related a little bit to this standard that we have, this OCI, and what that really means. You talked a little bit about it earlier, but could you maybe just define that? What is that? And like, is there new stuff going on there, or is that just kind of set in stone and we're just all working off that standard?
Yeah, that's a great question. So I mentioned, the OCI was founded out of this fear that if everyone ended up going a different way with, how we were going to use these kernel features, we'd lose interoperability and we'd have splinters of different groups, believing that their runtime did it the right way, and the usual uh, kind of falling apart of what was a fairly unified ecosystem. Um, so summertime 2015, OCI came on the scene. The initial focus and charter of that group was, let's create two specifications. A runtime spec would say, here's what we think a container is. It has these namespaces. You can optionally turn on and off certain ones, the PID and host namespace and network namespace. Here's how you define your C group limits. Here's how you give a name and a command, and here's how you pass environment variables to it. So all the things you kind of intrinsically might know how to do from a Docker command line, the runtime spec codified that in a very formal way so that anyone who said, hey, I implement the OCI runtime spec would know how to take a definition using that format and turn it into a running container. And so the runtime spec About a year later came out Runtime Spec 1.0, yay. And Image Spec did kind of the same thing for what is an image. It's this set of layers, it has this config, here's the media types. And so again, that same year came out with 1.0, the image spec. In some sense, I think the OCI lost a little steam at that point because it's like, okay, great. We have specs, we have Run C.
Yeah. Now we need to make, make tools. Yeah. Now,
let's all go back and make our tools
yeah.
and whatever. So I'd say there was a little lull, but especially second half of last year into this year, we have a ton of new interested parties in the OCI talking about some new things. One is an artifacts repository. And so I just mentioned images. Maybe you've dug into what an image is and you're like, oh, there's this thing called a manifest and it points to a bunch of layers. And my tools like Docker know how to pull an image and even pull the right one for my platform if it supports ARM and Windows and x86. And that's all because of this kind of standardized idea of an image. Yeah, but nowadays we have...
Most of us, by the way, have never had to deal with that, right? Like manifest, is that almost like, we all know about a Docker file, but there's actually this other thing that Docker does automatically for us. And I'm not sure how Containerd and cri-o handle it, but my understanding is like it deals with these manifests. It might even build the manifest for you. But if you're someone who's ever had to deal with multiple OSs, it almost seems kind of like magic because you do a Docker run Nginx on a Raspberry Pi and it works. And then you run that same command on Windows and it works. Maybe not Nginx, maybe like MySQL or Python or something. And then you run it on a regular AMD Linux machine and it works too. And some of us just might just shrug that up and go, yeah, it's Docker magic. Like, So you're saying that this is this manifest file and that actually defines the architecture and the OS and amongst many other things. So sorry, I interrupted you again, but
no, that good point. So I mean, that was an area I was steeped in. And so again, I sometimes think, oh, everyone, looks at these things and knows about this JSON format that has all these,
You made some cool tools.
Yeah.
You made some cool tools for discovering that stuff, figuring it out.
Right. So, these manifest objects are handled by your engine. Containerd knows about them, cri-o knows about them, Docker knows about them. And this is part of another spec that I didn't even mention. The distribution spec came after those other two that said, hey, everyone's talking to registries using the same Docker API that Docker created, and Docker Hub runs on this Docker distribution open source project. Let's just all agree that the distribution spec should start there. And we can genericize the name. It doesn't need to be Docker dash whatever.
Right.
And so the distribution spec hasn't reached 1.0 yet. But again, every registry from every public cloud and Project Harbor people are there. We have a great cross-section of people that have shown up interested to kind of finalize that spec. And then also where I was heading is that now we have other things that we might want to store in a registry. Helm charts, CNAB, the Docker app stuff. Software supply chain is a hot topic these days. And so there's a set of people that say, well, I'd also like to store like what it is that created this thing that's in this binary set of layers, like a software bill of materials that says I use this version of Go and these third-party libraries are included and I installed these packages. So all these things don't necessarily look like images anymore because, again, images have always just been this manifest and a set of tarred layers. So this artifacts work in the OCI is saying, let's create a repository of other media types that we know people want to use or already may be using. And we'll create a way for registry implementers to say, hey, I know how to support that, or I could support that, and I can search on it, I can filter on it. And so we're hoping to get a bunch of registered media types that will effectively standardize the different kinds of objects you might find in a registry in the future beyond just the images we've already talked about. And so the artifacts work has gotten a lot of people re-interested in the OCI. And then image signing is another hot topic. And so now there's an effort called Notary V2. It kind of sits between the OCI and the CNCF. They're having weekly calls. Again, most of the registries you probably use have people, representatives in those meetings, whether it's Azure or Amazon's registry or IBM's or Docker Distribution Project or Harbor. Um, most of those people are there and they're discussing, hey, how can we standardize on an image signing format and methodology that everybody can agree on? We can standardize it and there won't be any confusion about, well, I know this registry supports image signing this way, but OpenShift does it this way. So it's hoping to come up with a way to standardize that and reduce any confusion in the future, so that if you use a signing tool from Red Hat or Docker or your cloud provider, they'll all support the same way to sign and then check the signatures of images at runtime. So those are all kind of OCI things that when the OCI was started, no one was even talking about those things. But now they get kind of have brought new life to the OCI and a lot more participation and excitement about these new things to standardize, so that, again, development tools and workflows will have the interoperability that we just expect from images or running a container.
Yeah, that's really cool. I mean, obviously, I'm sure it's not within scope to like figure out how to, you know, do GitHub inside of images, you know. But the idea that we can store, I sort of caught onto this wave when Docker app was released, even when it was a separate tool. And so if you're watching this show and you go back in the archives of this channel, there's at least 2 or 3 talks, usually with Michael Irwin, um, talking about how there's a way in Docker app to store essentially your YAML, your compose YAML, but it could always just be, you know, kube manifest and other things. It's the configuration. It's the way to architect multiple container images into a solution. So the use case that people, when they talk about like Docker app, why do I care that this thing makes its own image? The use case I usually talk about there is that if you just want to ask someone just says, hey, how can I run WordPress? Well, you can't just teach them Docker. Like, how do I run WordPress and Docker? They have to learn Docker, and then they have to learn some other tool like Compose or something that can handle multiple containers, or at least orchestrate them in a little easier, so they don't have a bunch of different command line options they have to run. And then that file that they make, they have to go find that on the internet somewhere, because it's not in the same place that they find their images for WordPress and the database to run it. They have to go find that YAML file. Maybe in a README they'll be in a sample, but they can't really run that YAML directly. They usually have to copy paste, and there's this whole process to it, right? Just to run a simple little website with a database back in. And when they demoed it at DockerCon years ago, when they showed how you could use a Docker app command to store that YAML and some other templating stuff inside an image layer that would be a separate image, essentially like an artifact,
Right.
and that would be stored in the registry, and that you could ship that instead of the image itself. So it's a different command that instead of shipping the images directly and running them directly, it would download this YAML, look inside there, then see all the settings and the images that you need to run, and then do all that for you. And it just kind of clicked for me that as an operator especially, I can now version all of these artifacts, right? These YAML files where maybe I'm not in a team that's super GitOps focused, where we're not storing everything in Git commits, right? Maybe we're using Git, but we're maybe not using that as a way to ship product. And that's part of the CNAB spec, which I think you might have mentioned earlier, the CNAB. And that was like, to me, the first idea of like, how do we use a registry for more than just regular container images? And it's pretty cool to hear about other ideas in the industry from you around storing other types of artifacts in the registry that might either complement the container itself or be an alternative, maybe a precursor that is used to later on get images themselves. That's really neat. And I think that having these standards in place really means that we're probably a couple years away, I'm guessing, but we'll probably start seeing some other tools or enhanced functionality in our current tools to basically just make this deployment stuff easier, right? like
Yeah.
managing our applications and deploying them without having all this other work. Because you and I have been talking for half a decade about the container that we make, building it, and then there's the container we run, like usually Docker run or kube control run or something, and then there's this nebulous mess in the middle.
Right.
How do we ship it to the server? How do we automatically update it? How do we ensure the versions we're putting on the servers are the ones that we had on the registry? Like all these sorts of dozens and dozens of questions that come up when we're all talking about this stuff. And we're maybe not trying to solve all those problems with what you're talking about, but I feel like this is another layer of abstraction that allows that image registry to be more useful instead of us just creating more unrelated specs that say, yeah, it needs a URL. You need to store it in a Git repo or whatever, some other thing that's
Right. Right.
unrelated to the registry. Really neat.
Yep.
And that's called the distribution spec, right?
Yeah. So there's the distribution spec, which is codifying that API that we talk to registries
Yeah.
on. And then the artifacts repo will be the place where registry operators or other interested parties can go say, what are people trying to store and what should I know about it? Like, is there a workflow associated with Helm charts that's different than container images? And how are they made up? Like, what media types will I be storing? And will I need to provide a search or listing feature for this new thing that my registry will now contain?
Yeah.
So those are the two main pieces happening in the OCI around this.
Yeah. There's a couple of questions in the chat. There was one of them, a little bit related to our previous conversation. I wanted to know, how do we have any alternative to Container D? How does Dockerless? Got it. How does Dockerless build using builda podman / differ from it? So maybe they're asking, how does builda how is builda different? Because builda is what is building images, right? With the builda
Right.
podman. Yeah.
Yeah.
And
So,
yeah, go
yeah.
ahead.
No, I think I so one of the Red Hat messages around their tools is, Docker, we've always needed this daemon running, and maybe you don't want that. Maybe there's an environment in which you don't want a daemon, and so here's some tools that, because like I said, they build around these common libraries. They can interact with like the file storage where the container is without having to go through a daemon. And so that these tools are effectively daemonless. The alternative for that from the Docker tool set is actually BuildKit. So BuildKit does allow daemonless building of images by starting BuildKit and telling it to use Runc as the executor. So when you run a Docker file, when you build a Docker file, those run commands actually turn into containers that actually run and do that command. And so some runtime has to go do that.
Yeah.
And so in the Docker world, Docker has run containers for you. You can now use BuildKit and say, actually use Runc for that, which means I don't need a daemon. And so I think that's the alternative. If you're looking at build in Podman, is there something like that there's no daemon in the Containerd world? At least for building, yes, that's BuildKit. For running containers, we do not have a daemonless operation style in Containerd. We still expect that you're going to have a daemon and you're going to talk to that daemon. Again, that's our model was, this is going to be embedded in some daemon anyway, the kubelet or Docker. And so we haven't made it a design point to allow operation of like a run command without there being a daemon.
Yeah.
You can always drop down to Runc and do that. So if you want to dig into the details, Runc is not a daemon. Runc just directly runs your container, which is why you need something wrapped around it to be a Kubernetes runtime, because there has to be some daemon somewhere that says, oh, you want me to start a pod on this node. So yeah.
Yeah, and this is a good actually distinction, right? Like if this was like a session we were learning about all these different tools, there's a difference between building an image and running a container. And some tools like Docker have we just been spoiled. They're different commands, but they're different activities, and Docker just bundles all that activity in.
Right.
And the newest version of Docker, it now has this build kit, which is a new way to build an image, and they've broken it out, right? So it's a separate tool, but it's also now bundled into the Docker command line, so you can use it with Docker build X nowadays.
Right.
Um, or you can use it separately. I've not actually tried using it separately since they've shipped it in Docker, and I didn't really think about the idea of having it as my standalone build tool. That's pretty cool. Because I mean, I always saw that at first when they were showing the demos because they've been talking about BuildKit forever. Um, but I always thought that was just what they were showing for like their internal testing purposes, not really as a user front end thing. But that's a really neat idea. I'll have to revisit that.
Yeah, I have a very lapsed blog post idea. I have a GitHub repo for it already that actually works, but a lot of people have been using this Docker and Docker concept to do builds in Kubernetes clusters. Um, but you don't really need to do that anymore. There's all kinds of replacements for that. The whole Tecton
Yeah.
project, allows you to do that. But you can actually just do it with BuildKit simply. So there's actually BuildKit container images on Docker Hub today. And so you can create like a Kubernetes job that all it does is say, hey, here's a Docker file. Go build me a container. You don't need a daemon. You don't need Docker running. And so it's a cool little demo of just
Yeah.
building containers inside a cluster without any daemons, without mounting any sockets, without doing anything special.
And there's also a difference because we've been talking about these two terms. There's also a difference between rootless and daemonless. And I think I know in the past I get them confused because I'm thinking about one, but actually reading something about another. Or I read a blog post that talks about rootless Docker or daemonless, Podman. And my understanding is the way that Podman works is that it just controls system D. So technically that daemon is the same daemon process that your Linux system is probably already using for all of its other services. And that's how I understood when I started playing with Podman. I was like, well, how's this thing working if it's not running something in the background? And it's just the thing that you're already running. So it's not adding another service in the background that needs root. That's a pretty interesting way of doing it. And then we have the rootless stuff, right? Which I know Docker can be rootless. I'm pretty sure Builda and Podman can be rootless.
Yep.
Is there a rootless container D?
Yes.
Yeah.
Yep. Yeah. So, and that's one of those things where the same small group of people, Akihiro Suda is a name a lot of people will recognize. There are some folks on the Red Hat side. They all work together. They're all rootless experts and unprivileged container experts. And they've been working on this stack for years now, getting Runc to not need root, and then getting Containerd and cri-o to not need root, and Podman and Docker, and then Kubernetes. How can I run an entire Kubernetes installation without needing root?
Yeah.
So these guys are like the masters of figuring out where is privilege required and how can we do it without needing that privilege in the future, which sometimes has driven them back to making kernel changes or the C groups V2 work. So yeah, rootless is some hard work that's been going on for years, but effectively is different than daemonless. All it means is, can I do these steps to start a container or stop a container or create the network device to put in the container? Can I do this without root privilege such that I remove one more security concern from my whole stack?
Yeah.
So yeah, it's a lot of interesting work that's been going on for quite a while.
Yeah, and a lot of things there when you start comparing all these tools because they're all fundamentally related, but they all do different stuff, and I think that can be really hard for new people when they see the marketing around rootless Docker or daemonless Podman, and there's not always a one-to-one comparison with these tools because they all have a different scope of what they're trying to do. For instance, with what was I going to say? With Podman, it is not a container runtime for Kubernetes because my understanding is one of the reasons that wasn't in scope. That's what cri-o is for Kubernetes, but also because it doesn't have an API in it. Since it's not running a daemon, there's no Podman API for Kubernetes to talk to. So it would have to talk to systemd directly, which is interesting because now we got to wonder, okay, one day is systemd going to be a Kubernetes runtime? I mean, how does that, how do you classify that runtime? I debate, I have some friends in Red Hat and I debate around, is Podman really a container runtime? Because that's kind of what it classifies itself, but it's not doing the running. It's just controlling systemd for you. So these tools can be a little hard and the feature set can be a little different, but hopefully having Phil on the show, you listen to this hour of podcast and you now have a clear understanding of the status of all these things. Well, we've had some other great questions, and we were hitting an hour, so I definitely don't want to take too long. But one good question was, does Containerd have native support for image vulnerability scanning? That's an interesting idea for a feature.
Yeah, that's so good question. Most of the image vulnerability tools that exist, whether it's open source or from one of the big vendors, um, need to know where your registry content is. And so most of them plug in at that level of interacting with a registry. And since Containerd doesn't implement a registry or doesn't have access to kind of the back end of a registry, we aren't really the natural plug point for image vulnerability scanning. So native support wouldn't really make sense for our layer of the stack.
Yeah.
But definitely within a Kubernetes cluster and management control plane, that's where a lot of these tools plug in. And we definitely don't get in the way of that. There's nothing necessary to make these tools work better or worse using Containerd versus Docker. But yeah, it's a good question.
Yeah, and I agree with you. It seems like the kind of idea that should be in a higher level tool like the Docker command line, which tries to bundle as much as possible, or a Kubernetes cluster with some sort of additional CRD operator or something. And for the question, when we're talking about image scanning, so with the projects I work on, there's two types of image scanning. There's image scanning during the build, which since Containerd doesn't build, then obviously it would not be related to that. But you could do it as a line in your Docker file to scan stuff inside the image while it's building. And then there's other tools that build after the image is built, or while it's in a registry, it'll even download it and scan it locally from a registry. So those tools could potentially work against Containerd because it would be in the image could be in the store and it could do a pull and then run that container to scan it and all that stuff. So I'm trying to think about the major tools, and of course they give a lot of examples around Docker because Docker tends to be that tool that we all use in CI for testing containers or for local human use when you're manually scanning images. But now what we're seeing with Kubernetes is some of these higher level tools are building this in as a feature or standalone tools that automate that. So yeah, definitely check that out. It seems like you have someone who's a fan of the idea that you had for your Git example, because the last question here is, can you share the Git URL? I'm assuming that they're asking for your example of your
the build kit
example.
Build in the cluster example. I think that's what is being asked. So I actually did post it there. The build kit cluster example repo on my Estes P GitHub. I was again shocked at the passing of time because it looks like I created that last March, and I thought it was much more recent. So it probably hard codes, like it says build kit version 0.4.0 in the README, which was released in March 2019. I bet there have been a zillion build kit releases since then, and so I would highly recommend using the latest version. But other than that, this example should still work.
Can you send it to me in Skype? Because I think YouTube is blocking it. I don't see it on YouTube.
Oh, okay. Yeah, maybe.
It doesn't like links.
Normal, hi there. Let me send you the link in our chat.
All right, well, we're getting ready to wrap it up. So if you have any last minute questions for Phil, definitely get those in. And of course, I'm going to post his little build kit cluster example that hot off the press. See if we can get that in there. Of course, all these will be in the show notes if you're listening to this later. So where can people find you on the internet?
Yeah, so Twitter's easy. At Estes P on Twitter. I'm same on GitHub. I do try and keep an update of where I'm speaking. So yeah, you've got my estesp.dev site up. So that gives a little more, some links to various things I'm involved in, like the Technical Oversight Board or the OCI, um, and then talks and, links to GitHub projects. So yeah, that's a good spot. And then when I do blog, which sadly has not been since August 2019, integratedcode.us is my blog. And so I have some ideas to hopefully get some things out this year, content-wise. But yeah, lots you can find there already. And as Bret said, I tend to travel around talking about Containerd a lot, so I catalog those with links to the videos on the estesp.dev site. So yeah.
Yeah, and you definitely want to follow him on Twitter as well as the Containerd project. They have their own Twitter handle at Containerd, so you can see
Yep.
all the latest announcements and stuff happening in that ecosystem. Last thing is, I realized, is there a repo or a way to follow some of this the distribution stuff? Is that, I mean, that's not, is that still in Docker distribution, or are they kind of moving that somewhere else? Do you know?
So yeah, that's actually that's part of the Open Containers GitHub repo. So that's if you go to GitHub/Open Containers, all one word. That's where the runtime spec that we mentioned and runc, but there's a distribution-spec repo there. So that's about the spec we talked about. And then there is artifacts, which again details the new work around media types for other things like Helm charts and non-image content that you might want to store in a registry. So
Yeah.
artifacts and distribution spec are there along with a lot of other content. And we have a weekly call. So if you're like, hey, this is, I'm wanting to dig into the details, you can look at the overall OCI project or the opencontainers.org and get info on our weekly call.
Very cool. Yeah. And I'm sure there's some people on the call that want to get a little bit more in depth to this stuff because there's a lot going on underneath your runtimes.
Yep,
Yeah, that
absolutely.
makes all this stuff happen. And it's as you get more mature in your container learning, definitely, I think you should be checking these tools out, which is why we were going to be at KubeCon talking about it.
Right.
So hopefully we will, if not before, we will see each other in KubeCon EU at the end of the summer, assuming that goes well and we don't have any more coronavirus. But we'll see.
Yep.
We may be doing a virtual conference this year. So thank you so much again. And now, by the way, for those of you that are listening, this is like, I think we tried to figure this out. I think this is Phil's at least third time being on the show. And I think the reason I couldn't find the old videos is because I used to have a different different channel on YouTube, my old personal channel before I made this channel. And those videos are over there. So I'll probably post some of those old videos in the notes in case you want to go back and look at the early days of Containerd when we were all talking
Yep.
about the 1.0 and the 1.1 releases. So, well, thanks again, Phil. It's been great to have you on the show. We will definitely have to see each other. We're only 3 hours apart in the real world. So at some point, we have to figure out a way to see each other in the real world instead of virtual. But I appreciate all this detail. I'm sure that this will be great. And if you're watching the podcast, we'll have this, I don't know, in a month or so, we'll have this episode released on the podcast so you can listen to it on your commute or however you listen to your podcast. And thanks again, Phil.
Yeah, great to be with you as always. So
Yeah, we'll see you
talk to you
soon.
soon.
Yeah. Thanks, everyone. See you next time.